What's up, everybody? Welcome back to another live stream from Scalar Learning. And this is your weekly Saturday live stream, which means we're back on SAT math. All right, let me just make sure everything is running smoothly and we're looking good. Here we go. Let me just make sure one other thing. Yeah, all right, cool. And audio is good. Let's do it. So today we are jumping into, let's see, operations with polynomials, level 3. Operations with polynomials. Here we go. Oops, where was it? Oh no. Oh shoot. No, we're supposed to be doing, oh, my bad. This is actually supposed to be polynomial factors and graphs. Excuse me, I think I didn't change that description. Hold on, where are we at here? Polynomials. Oh yeah. So this is, we're supposed to be doing polynomials, factors, and graphs. This is what I did last time. Hold on, let me fix this. Polynomials, factors, and graphs. I thought I fixed it. Yeah, there we go. Let me just change this really quickly. Polynomials, polynomial factors, and graphs. Oops. All right, almost ready here. Factors and graphs. Okay, hopefully that updates correctly and we're good to go there. All right, here we go. All right, the polynomial function g is defined above. When gw is divided by w plus 16, the remainder is r. What is the value of absolute value of r? Okay, this is interesting because now we're talking about we're talking. This is actually a pretty hard question. I think I know how to do this, but I think what you can do, I think a shortcut of what you can do is you can just plug in negative 16 into this equation. So I'm gonna think about this two ways. So the first thing that I know is when you're trying to figure out what a factor is, or what it evaluates to in terms of the remainder, you can plug in essentially like this dividing by this would be the same as, I believe, plugging negative 16 in, whatever makes this go to 0. So if I were to plug negative 16 in, I think this is how one shortcut how you can approach it. Then I'll show you another way that is going to be a lot longer. Negative 16 plus 13 cubed. This is a calculator problem. 19 squared. So this is negative 3 cubed, which is negative 27, times this becomes 3 squared, which is 9. That's 180 plus 63. 180 plus 63 is 243 negative. Okay, so I think that's the answer. Well, absolute value of that is positive 243, right? Okay, so let's say I think that's what it is. Now let's do it the lengthier way, where we could actually do synthetic division. So here, let's do this. I'm just trying to see, because the other way I'm thinking it's going to be quite lengthy, but let's go for it. So what I'm going to do is I'm going to FOIL this out. So I'd be like w plus 13, w plus, oh, wait a minute. We can just, I know, there's a shortcut for this. That becomes, oh no, that's factor, that's, yeah. There's a shortcut for this, but let's just FOIL it out like this. W plus 13. Okay, so it's w squared plus 26w plus 169, okay, times this, and this becomes w cubed plus 26w squared plus 169w plus plus 13w squared. 13 times 26, 338. Right, 338 w plus 13 times 169 times 169 equals, you can already see how this is going to be a little crazy, 2197. So that's w cubed plus 39w squared plus 169 plus 338, 507, 507 w plus 2197. And then this times w plus 19 squared is, this is clearly not the way to do it, I'm realizing, because it's so lengthy. W squared plus 38w plus whatever 19 squared is. 19 times 19 equals 361. I'm going to probably abort this because, okay, so what I was going to do was I was going to get the big polynomial function that results from this, which is going to be humongous. It's going to have, let's see, 5, 1, 2, 3, 4, 5. It's going to have like 6 terms. It's going to be to the 5th power. And then I was going to do long division. That definitely cannot be the way. So my assumption is what I evaluated up top. Oop, where did that go? Did I delete it? Yeah. I think it was 243, right? My assumption is it's 243. Let me enter it. Let me see if that's correct. And if it's incorrect, let's figure out why. All right, it is correct. So now let's just make sure that they did it the exact same way. Yeah, so the exact same thing. They plugged in negative 16. They evaluated the whole thing, and they got it. So that's the shortcut. This is would foreseeably work. It's just so time intensive that it's ridiculous. Now, let me clarify, because I actually don't think you're going to get something quite this difficult ever on the real SAT. I've never seen anything like this on any of the practice tests or any of the real tests that I've taken in the last few years. That being said, that's the shortcut. So just plug and chug. All right, here we go. A function p is defined as this. Given that p of 7 equals 15, what is the value of a? Okay, well, this is what I'm going to do. I'm just going to plug and chug. So p of 7 is 15. So 15 equals 7 minus a. See how I'm plugging in 7 for all the x's, times 7 minus 15, which is negative 8, times 7 minus 20, which is negative 13, plus 15. Okay. So we just got to solve for a. That's it. Let's subtract 15 from both sides. First of all, I get 0 equals 7 minus a. It's 7. I already know. But it's, okay, so then we do negative 8 times 13 is 80 plus 24 is 104. Positive. Okay, and then instead of distributing, I'm just going to divide both sides by 104 and get rid of it. And that goes to 0. 0 equals 7 minus, 7 minus a, therefore a equals 7. All right, next. A function w is defined as this, where a, b, and c are constants. If a equals 3, okay, so I'm just going to plug and chug, and w of 3 equals w of 15 equals 0, strange. Okay, so what is the absolute value? Okay, so let's just plug and chug. So first of all, I know that w of 3 is 0. W of 15 is 0. So let's plug these in and let's try and figure this out. So first of all, a is 3. I'm replacing that a, and then x squared plus bx plus c. And this is the case when my x, we're plugging in 3 for x. So let's first plug in 3. Hold on. And then this will be the second function where we're plugging in 15. Okay. Right? So there's my 15. Okay. I'll kind of do it slightly simultaneously. 3 squared plus b times 3 plus c. And this is 3 times 15 squared plus b times 15 plus c. Okay. So this is 927 plus 3b plus c equals 0. And this is 225 is 675 plus 15b plus c equals 0. So I can set these, so since these are both equal to 0, I can set them equal to each other. And I'll just say, here, let me move this up a little bit more. 27 plus 3b plus c equals 675 plus 15b plus c. The c's cancel out, right? And then I can subtract 3b. And I get 27 equals 675 plus 12b minus 675. This is a calculator question. I might use it here. Let me think about it. 48, but I'll just double check. 675. Okay, and then we're going to divide, then we're going to divide both sides by 12. B equals 54, negative 54 in this case, but they want the absolute value, so it's just positive 54. Because on the real SAT, you actually can't, you're not supposed to ever have a negative in the grid-ins. Okay. There we go. Question 4. Question number 4. A function S is defined as this. Function H is defined as this. For some constant A, hold on here. For some constant A, x minus a cubed is a factor of H. Okay, hold on. I'm trying to wrap my head around this. What is S of A? That is a factor of... Hold on. Oh, I see. I see. Okay, let me rewrite this. I got confused here because I thought that was like a constant, but that's that function up there. So h of x, I'm still haven't quite wrapped my head around this, so I'm going to write it out like this. X minus a times, and then I'm going to plug in the function here for that s, x minus 4 times x minus 5 squared. Okay, and then it says for some constant a is a factor of this. Okay, got it. So x minus a cubed. Oh, I got it. So this is supposedly a factor of this function. Well, wait a minute. If this is to the third power and it's a factor of this, then something up here has to be to the third power. I mean, it only makes sense. I think that's what they're going with. And look, the only way possible for you to have anything to any binomial to the third power was if a were equal to 5, because if a were equal to 5, then I can combine these, and it's no longer x minus 5 and x minus 5 squared. We combine it to x minus 5 to the third. Okay, which stands to reason then, let me just reset this back. That stands to reason that a is probably 5. Okay. All right, so a is 5, which means, and then they're asking what is s of a. So now we have to plug a back into s, so I'm going to assume that that's 5. I hope this is correct. We have 5 minus 4 times 5, that's 0. That's 0 times that is just 0. Let me just wrap my head around it some more, because I'm wondering if that's a little too easy to just put 0 in. X minus a factor of h. So if it's a factor, then, all right, I'm going to go with it. I can't think of any other way to tackle this, so let's see. Hey, it's right. Let's see how they did it. X minus a squared is a factor, since x minus a squared... Oh, wait. So they have a slightly different method that I did. Because the non-sx part of x minus a counts for one of 3, we conclude that the other 2 are in s of x, which I did, right? I concluded that the other 2 had to be these guys. That is, we conclude that x minus a squared is a factor of sx. Okay, sure. So they're just basically saying this has to be a factor. Therefore, if it's a factor, we're plugging a in. It's going to give us 0. I think I took it a step farther by assuming that the a had to be 5. But so I guess you didn't need to do that. Okay. Last question. 12x squared plus ax plus 2. If one of the zeros of the above polynomial is 2/3, what is the other zero? Okay. I think the best way to do this is using the quadratic formula. Yes. Okay, quadratic formula. Negative b plus or minus square root of b squared minus 4ac over 2a. So this is, my b is a in this case. Negative a plus or minus square root of a squared minus 4 times a times c. My a is 12, my c is 2. So 48 times 2 is 96. Over 2a, 2 times 12, which is 24. All right. Now, hold on a second. So one of these is going to equal 2/3. So 1 0 is 2/3, and the other one is whatever. We have to figure that out. Now, the problem is... So 2/3 for this, that means the top would have to be 16. So it's like, see, I don't know if it's, that's the interesting part, is I don't know if it's the plus is the 16 or the minus is the 16. But anyways, look, for this to equal 2/3, all right, I have to, first I'm going to isolate and solve for a. So I'm going to multiply both sides by 24. 24, and get rid of that. 24, 2/3 of 24 is 16. So negative a plus or minus square root of a squared minus 96 equals 16. Okay. Now I don't know if it's the plus or the minus is my point. So I'm going to just go do 2 separate ones and see if this gets me anywhere. It's negative a minus c. Let's just see what happens if I do this. I'm wondering if there's a better way to do this as well. 2/3. Oh, wait a minute. There is a better way. I just thought of it, but I'll come back and finish that in a second. I just realized if one of the polynomials is 2/3, then, if one of the zeros is 2/3, that means one of these guys has to be 3x minus 2. Because if I plug 2/3 into this, if I factor it, I plug 2/3 into that, I get 0. Which means that I can factor this pretty easily, and the other one has to be 4x plus 1. This gives us a negative 1/4. Negative 1/4. Because you're not supposed to, they've made mistakes like this. It could be a negative answer, but you're not supposed to have negatives in the grid ends. Let me think here before I enter this. 1/4. Which means my a value, as I've done it here, is, hold on, 3x. 3x, negative 8x. So a is negative 5 in this case. Negative 5. Right? I think I'm going to go for it, but... Here, let me just try one thing. So a is I said a is negative 5, right? Now, I know I wouldn't normally get Desmos. So my answer is going to be negative 1/4. All right, I'm just going to roll with that. But I just want to see something on Desmos to make sense of this whole thing. So we're looking at some function like this where it's supposed to have a 0 at 2/3, right? So 12x squared. So I'm saying minus 5x plus 2. Oh, wait a minute. That didn't even work. Hold on a second. I must have done this wrong. So 2/3. Oh. I factored it wrong. I just realized. It's got to be minus, because that's the only way we get positive 2. That's where I made a mistake. So 12x squared, negative 3x, negative 4x. A is negative 11. 12x squared minus 11x, and then plus 2. Negative 3, negative 8, 11. Okay, now we got it. Which means that my 0 is 1/4 positive, not negative. There we go. Now let's go back and let's graph this just for confirmation. This was just to make sure, just to see that this made sense. And then look, there we got a 0 of 2/3, and then we got a 0 of 0.25, or 1/4. Okay. Yeah. Let's just make sure they... Okay, that's how they did it. Okay. Oh, that's much easier. That's much easier. They plugged 2/3 in and set it equal to 0. I don't know why I didn't think of that. All right, so there it is. Those are the problems for today. Now, just a quick note. Like I said, I think these are actually level 4 problems. I think I marked this as level 3, but these are really difficult. And I got to tell you, these are great, I think, practice and great to push your limits, but they're not representative, I think, at all of what's going to be on the SAT. These are definitely harder. So it's good principles to know, but I don't think they will be this level of complexity. Maybe, arguably, the last one might be, and there was perhaps one in the middle there that was SAT caliber. But I'd say the majority of these problems were very difficult. So just take them with a grain of salt. Let me just make sure we don't have any other questions, and we'll kind of be good to go. I make memes. Hi, Huzaifa. Your videos are educational. Keep going. Oh, thank you. You're welcome. Hey, what's up, Ayush? All right, guys. So that is it for today's live stream. Again, I'll see you all tomorrow at same time, 7 a.m. Pacific Standard Time. Please click the like button if you enjoyed this video and you found it helpful. Really appreciate it. And last but not least, if you haven't done so yet, click subscribe so you can get more up-to-date information on all your standardized test prep mathematics needs. That's it for today, and I'll see you guys next time. Take it easy.